Hello, this is Chef Coding. Welcome to another episode of my Erlang tutorial series. And today I will be talking about guards, the if clausal, and the case clausal. Okay, so without further ado, let's go. As you can see, I already prepared a module and 3 functions to make this video shorter, and I will only talk about it. And I think this is the way which I will be approaching in the future. Okay, so let's start with guards. Guards help us to pattern match even better our values in the function calls. As you can see, this is something new, and this is a guard. We are specifying guard after when keyword. You can say it's keyword because we can't bound it to any variable. Let's try. Okay, we got syntax error. And after this keyword, we have to specify an expression which evaluates to some boolean, which mean true or false. Here we can use lazy versions of logical operators and also or else, compare operators, and some functions, but not all, only the functions which are called BIFs, which stands for built-in functions. These functions are listed here. I will put this link in the description. This is official Erlang site, and this is documentation of modules. And BIFs are stated in the module which is called Erlang. And here is the list of our BIFs. Here I can show you the most used one are this one, which starts with prefix is and underscore, is binary, is atom, is integer, is function, is map, is list. So these are which are the often used in the guards. And here you can see that in my function horniness level rating, which takes one argument level, I'm checking in guard is integer, this level, and also is this level greater or equal to 10. After that, we are putting the arrow just like in normal function clausal and specifying the function definition. As you can see, I created many function definitions with 3 different guards. Here in the next guard, I am also checking if this level is integer and is greater than 5. Also, I am checking in the last if it is even integer. Why it helps with pattern matching? It helps because we won't get pattern matched our level if the guard specified after the function name does not evaluate to true boolean. If this get pattern matched, but guard will evaluate to false, then the arguments won't get pattern matched and go to the next function definition, tries to pattern match in the next one. And this is how it is. Let's try to compile our file. Okay, we didn't got any errors. So let's try to put some arguments in our horniness level function. Let's put 10 here. And we got you are super horny, go to horny jar, the expected output. Now let's try with something like 8. And now this pattern matching will fail because the requirement of level being greater or equal of 10 is false. So, and also we will return false. It will go to the next function definition and try to pattern match here. And this guard will evaluate to true. So let's see if it really does. Yes, that's true. Be careful, you are starting to be horny. Nice. Now let's try even lower number. Let's try with 2. And yes, your horniness level is decent. That's correct. Now let's try to put uwu, and we got bonked, and that works just fine. Now let's try to put something which is not integer and not uwu, and we got exception error, no function clausal matching, episode 5, horniness level rating 12.5, and that's true, because let's see, we have only 4 function definitions, and 3 of them has this isInteger guard, which always fails when it comes to floating point number, because float is not integer, right? This won't get pattern matched for float. The last one is U, atom U, so it won't get pattern matched also because it's 12.5, it's float, it's not U. Only U gets pattern matched here. It fails with the last one definition, so it didn't get any pattern which fits to this value. That's why we got this error. We have to always think about it when we are specifying functions and try to pattern match value there. Okay, let's move to if clausule. And if is very similar to guards. We are using if keyword, and after that we are putting actually always guards. There has to be guard. I talked about bifs because we in guards we can only use bifs. The built-in functions, we can't implement or define our own function which evaluates to true or false and use it here. Only the bif functions can be used here. In if syntax, we are firstly specifying some guard without when keyword, just guard. And if this guard evaluates to true, then after arrow, there is the definition of the expressions in Erlang, which will be evaluated. We are going out from this if block. We won't check the other guards. The first one, which returns true, is going to be executed. And the cases in the if block are separated by semicolon. That's also important. And as you can see, I am using here bifs, some lazy operators and compare operator. And let's try to use this function, define type. Define type, and let's try maybe with atom, some atom. This is atom. And we got the return value, it's atom. Now let's try with some integer, but lower than 5. Let's say 4. And we are trying to pattern match to atom. This evaluates to false. We are trying to pattern match to this guard, and this guard also returns false because this value is not greater than 5. And we are going to next guard, and this guard evaluates to true. It's integer and it's less than 6, and this is the output which we got. Now let's try with bigger integer, 7. And we got only output, it's integer and it's greater than 5. And yes, that's also true. The 7 is integer and also is greater than 5. So it got pattern matched and it evaluates this expression. And it's not actually expression, right? It's just Erlang term. And so it returns this term and it moves out from the if block. We are not going to check the next guards because it already get pattern matched. This guard would also return true, but the earlier one already returned true, so we are not checking the other ones. Let's try some tuple here. Let's pass the empty tuple. And yes, it returns the last case of in the if statement. And now let's try to put here some value which won't get pattern matched in these guards, but I'm not sure what it can be. Okay, so let me delete this float guard and pass here a float number. Select 12.5. Sorry, I have to compile this module after the change. And now let's try again the same. And we got exception error. No true branch found when evaluating an if expression. And it's true. We didn't get pattern match our value in any guard. And the if statement has ended. The end is keyword, which has to be put at the end of if expression. Our value didn't get pattern matched. So our exception error has been thrown. To prevent this error, we have to always put the true value in our guard, because it always pattern match to true, right? True is true. No guard is pattern match. Nice. And as you can see, I am separating all cases with semicolon, right? But there is no other case after the last one, so it doesn't need to be separated. So we won't put the semicolon at the end of the last case. Just after the end, we can put comma if we are gonna to put some other expression after that. If not, if this is the end of our function, we are putting dot or semicolon if there are some other definitions of this function. But I don't have any, so I put just dot. And now when we compile our module and try to do the same thing, we will get no guard has been pattern matched, and that works just fine. Okay, let's move to our last topic of this episode, the case expression. I prepared this function, lie detector, which takes one argument statement. Firstly, I am defining some variables, lie output and the string bound to it, the true output, some string also, and not sure output also has been bounded to some string. And here I am putting the case expression. This is the syntax of case. The case keyword. After that, the statement, which we will be trying to pattern match. And after that, the of keyword. And here are the patterns, which we will try to pattern match our statement. If statement is true, then this works the same like the if expression. If we will get pattern match to the left side of our arrow, then the right side will evaluate. So it's the better version of if expression, and I can tell you that in my professional career I didn't write a single if expression in my code. I'm always choosing the case expression because I think you can do much more things with that. Also, you can see that you can even use guards here. So it's very similar to the function clausal pattern matching, right? You are trying to pattern match some value to some patterns. Yeah, so let's try to use this function, lie detector. Yeah, let's start with 2 plus 2 is equal to 4. The truth has been spoken. That's right. The 2 plus 2 is equal to 7. That's obvious lie. We got pattern match to true and to false. Now let's put here some string. Magnus Carlsen is goat. The truth has been spoken. Yeah, the true output is that the truth has been spoken. That works fine. Let's try with some other strings, which are is great, serious. That's obvious lie. Yeah, that correct. And some other string that fits you perfectly, babe. The truth has been spoken. Yeah, that's always true. Let's pass it the tuple and let's see how the guards work here. You passed tuple to lie detector. Why? Yeah, why would you do that? And the last pattern, it's kind of odd. In case statement, if the pattern has not been found to the value which we pass to case expression, then we will also get an expression error. So to prevent that, we also have to make sure that all values which we are passing here will get pattern match eventually, right? But if we don't know what we'll get here as value, then the good behavior is to put this underscore variable, because it get pattern match to everything, right? We can actually put here any variable we want. It will get pattern match just as good as underscore would. If we want to use it, for example, we can put it as, let's try to compile it. And put some value which is not gonna to be pattern matched. Let's put some 12. and we will get 12 because it gets bounded here, because any value is always pattern matched to just single unbounded variable. And as you can see, only the last term is returned after that. We got here not sure output, but after that we put comma and this any value is evaluated as last expression. So this is what it will be return. You can put here hello, and hello will be a return. Now let's remove this any. Let's get back to the previous version. Let's compile and let's put here hello, and our lie detector will return I need some more information string. Yeah, so that works perfectly fine. As you can see, this syntax is very similar to the if expression. The last case doesn't require to put semicolon at the end. Just we have to worry about semicolon or dot or comma after the end keyword. And yes, that's all in this episode. Hope you learned something and see you